In this video, I would like to demonstrate that parameters of formulas have a very important role. And what I'm going to do now, I'm going to show you 3 examples from mathematics. I'm going to define 3 concepts from mathematics, and I'm going to give their definition in predicate logic. So let's check out the first concept here, which is about checking if 2 lines x and y intersect each other. Or in the second one, we want to check if the number x is less than another number y. In a similar way here, we want to check if a number x divides another number y. As I told you, the definitions for all those 3 concepts are expressed as predicate logic formulas, because predicate logic is very expressive. It's expressive enough to describe the mathematical concepts. Let's check out the first definition. So here we can say that 2 lines x and y intersect each other if they are not the same and there exists a common point. By common point, we mean that that point z is contained by both lines. Of course, here I'm using 2 predicates, point and contained. These predicates should be defined as well, but now I'm not going to give the full definition. I just wanted to demonstrate that here we use a predicate logic formula. I also want to note that this formula has a single bound variable z, and all the occurrences of z are bound, and also all the occurrences of x and all the occurrences of y are free, or rather we can say x and y are parameters of this formula. And this is actually this should be actually the case, because as you can see here, x and y are supposed to be parameters to this actual predicate, this intersect predicate. So this is actually pretty all right. Okay, let's talk about the second example, which is very similar to the previous one. We have one single bound variable z. All the occurrences of z are bound. Basically, we are looking for a positive number z, which if we add to x, then we get y. So this is why we can say that x is less than y. And also, similar to the previous example, all the occurrences of x and y are free, which is what we need here. We need x and y to be parameters of the formula. And the same happens, of course, in the last example. I'm not going to give further explanation there. What I would like to highlight at the end of this video is that parameters has this important role that basically, since they are free, you can substitute any value into those parameters. For instance, what if we substitute 2 numbers, let's say 5 here and 10 here. And what does it mean? Well, it means that actually we substitute the same values into the free occurrences of those variables. And now I have a formula which I can evaluate. And of course, if you evaluate this formula with 5 and 10 inside, you can get the value of this formula, which is true. I mean, 1. This is a true formula. Or you can substitute 3 into x in the third formula and 15 into y, and then you can evaluate the formula after substituting those values into the free variables, and again you will get 1 as the actual value of this formula. Of course, if you substitute other numbers into those parameters, then you might get another final result. You might get 0 as well. So this is very important to understand that in predicate logic, the value of formulas does depend on what actual values you substitute into the parameters of that formula. This is something you should understand and you should recall later on in the next module in these lecture notes.